was prompted by a Mars family member to look at what we could do to help the purebred dogs. We had gathered all of this information about purebred dogs in order to figure out what the mixed breed dog was composed of. But how can we leverage that information to help purebred dogs as well? Um, and I said, well, I have this philosophy of purebred dogs being like endangered species. Their genetic diversity is fairly small within any given breed. I mean, it's vast across all of the dog breeds, but within any of the 400 or so recognized dog breeds in the world, it's a lot narrower genetic pool. So how do we work to maximize the health of that population within a breed by maximizing the genetic diversity? Because we do know that a lot of conditions are genetically related. So, but we don't yet have a genetic test for them. Hip dysplasia is a key one where there's a number of genes involved, but we don't have, a test yet that can go in and diagnose, okay, you have this and this and this gene. And if you went and bred to that dog, you'd, produce puppies that had hip dysplasia 90% of the time or whatever. We don't have that yet. So my idea was if we can, work to maximize the genetic diversity within a small population, we can increase the health of the breed. Also, as breeds get kind of more and more limited in their gene pool, get more and more inbred, they tend to have reproductive issues. So lower levels of number of puppies per litter and that sort of thing. Fecundity tends to go down. And we've seen that across a number of species. We've also seen implications in the health of the semen. So the semen motility and morphology and such like that tends to decline as the male is more and more inbred. So needless to say, I took this information and said, okay, how can we leverage the genetic data we have to work within a breed to maximize the genetic diversity, and developed what was at the time a first of its kind genetic diversity test for breeding dogs, essentially. So you could genetically map a female and a couple of different males and then say, okay, which of these males would be most appropriate for the genetic diversity composition. And I worked with a very keen breeder, Miriam Couteau, in the Dandy Dinmont Terrier Club, who was here in Washington State. And she kept meticulous records on the breed. There was only about 42 Dandy Dinmont Terriers produced per year and registered with the AKC, so an extremely small population. On average, at the time, they were getting roughly just over 2 puppies per litter on average. When we incorporated genetic diversity into their mating decisions and looking at that component as well, we were seeing over 6 puppies per litter on a regular basis. So they were seeing litter sizes they hadn't seen in quite some time. And so that was really fabulous because, again, that's an easy way to analyze if what we were doing was working on a very short-term scale. Obviously, longer term, hopefully keep the genetic diversity from declining and bottlenecking and keep it healthier by looking at that combination. So anyway, that kind of sparked a bit of a revolution within the dog breeding community. And so now there's a number of tests on the market that do something similar. And I just encourage breeders to really think about genetic diversity when they're making their breeding decisions as well.
So, how aware do you feel people are about those tests?
Within the breeding community, obviously when we first introduced it in like 2011, 2012, this was a very unusual concept and it wasn't always super well taken. Interestingly enough, the cat breeders, when we introduced it to them, probably 5 or 7, 8 years later, they were very keen on it because they have a different philosophy. Cat breeds oftentimes are really based on, kind of one mutation different. Your Himalayan is a Persian, but with the pointed gene. Your exotic is a Persian, but with the short hair gene. So they kind of take a one-off approach, but that means that they have a very, very limited gene pool and they know that. So they are much more willing to outcross to another breed. And that's pretty common in cat breeding. I think for those reasons, they tend to approach it a little bit more aware of genetic diversity and genetic bottlenecks and maybe are less precious about maintaining the purity of their population, because otherwise they wouldn't have any cats. They just literally wouldn't reproduce because they wouldn't have any genetic diversity. Whereas dog breeders, have had the benefit of a lot more genetic diversity and a lot longer history. So cat breeding really is, primarily in the last 60, 70 years that we've had a lot of cat breeds developed. But dog breeding has been pretty popular for a few hundred years for all of these different breeds. Most are, 100, 200 years old. Victorian England really made an increase in the number of different dog breeds. They are, I think, a little bit more precious about, this is my purebred, population, and I'm not going to do any kind of outcrosses. And line breeding is much more common in that scenario. So I think it took a little bit more convincing and education on the part of the dog breeders. That said, I'm not really a part of the Wisdom Health team anymore, so I'm not on it day to day. But in my own personal life, I now have a Welsh Springer Spaniel whom I'm hoping to finish her championship and then eventually breed her. And so I'm hearing from breeders that are using genetic testing. Right now, I think they're probably more fixated on the genetic health mutations, so for specific mutations for certain diseases. But I see them embracing it, I think, a lot more readily than what I saw a decade ago, which is very exciting.